All right, today's lesson is on complex numbers. So we were working with just imaginary numbers. Complex is simply where we have a real and an imaginary part. So a plus bi, where a is a real number, and then the second part here is our imaginary. So when you combine them, it makes it complex. Okay, we're going to start simple by just adding and subtracting complex numbers. So here I have 5 minus 7i plus 2 plus 4i. Okay, so adding, really I don't need these parentheses, they're just there to separate the two numbers. So 5 minus 7i plus 2 plus 4i. This is really as simple as combine your real numbers, combine your imaginary numbers. So 5 plus 2 is 7, negative 7i plus 4i is minus 3i. All right, here's another example. 4 minus 8i. This time, let's subtract 3 minus 6i. So when you're subtracting, what you need to do is distribute that negative, so you're subtracting both. So 4 minus 8i minus 3, and then this turns into plus 6i, and now you can combine. So combine your real parts, combine your imaginary parts. So 4 minus 3 is 1. Negative 8i plus 6i is minus 2i. All right, now let's multiply complex numbers. So 2 minus 3i times 4 plus 5i. So what does this look like? It looks like two binomials, so we have to FOIL them. All right, so here's first. 2 times 4 is 8. Outside, 2 times 5i is 10i. Inside, negative 3 times 4, so negative 12i. And then last, negative 3i times 5i would be minus 15i squared. So let's see here, we've got 8. Let's combine these. That goes down to minus 2i. Now remember from our last lesson, what is I squared? That would be minus 15 times I squared is negative 1. So this actually turns into a positive 15. So now when we continue simplifying, I have 8 plus 15 and then the minus 2i. So 23 minus 2i. All right, let's do one more of these. So 3 plus 4i times 7 minus 2i. And why not? Let's do the box method, because I know some students prefer the box method over FOIL. So you could FOIL it right now and then just check your answer with my box method if you want. Or let's do 3, 4i, 7 minus 2i. So 21, negative 6i, 28i, and negative 8i squared, which is negative 8 times negative 1, which is actually positive 8. That I can combine with the 21, that's 29, 28i, and negative 6i is 22i. All right, 2 more examples, and these ones I would say can be quite challenging. So it's called rationalizing the denominator. So if I have 4 plus I over 5i. The idea is we want to communicate in a way that we can all get the same answer. So the rule is we want to get the i's out of the denominator. So what I'm going to do is multiply the numerator by I and the denominator by I, because I divided by I is just 1, and multiplying by 1 doesn't change anything. We're just going to change how it looks. We're just manipulating it. So on the top, I'm going to distribute the I, so it's 4I, and then I times I is I squared. And then my denominator, multiply here, so that's 5I squared. Okay, let's see, 4I, well, this I squared turns into a -1, and the denominator is 5 times -1. So now I have 4I minus 1 over -5. And technically that negative should be brought out in front, like that. There we go. Okay, last example, 2I over 3 plus 6I. So we don't want I in the denominator, but this time we have a binomial. So I can't just multiply top and bottom by I. You have to multiply by what is called the complex conjugate of your denominator. So what you do is we do 3 and 6I, but if this is plus, we do the opposite. This is now minus. 3 minus 6I. And now I have to multiply all of that. So my numerator, I can distribute. So that will go to 6I minus 12I squared all over, okay, my denominator, I need to FOIL. 3 times 3 is 9. Now I've got outside is -18I, and inside is positive 18I. When you are multiplying by complex conjugates, these middle terms are always going to cancel out, and that's kind of why we do this. Okay, and then I still need to multiply by last terms, which is minus 36I squared. All right, so let's break this down. I've got 6I minus 12 times -1 over 9 minus 36 times -1. So 6I plus 12 over, that would turn into 9 plus 36, which is 45. Now, I would be pretty happy if you ended up with that answer, but technically, the numerator, I could divide both by 6 and be left with I plus 2 over 45, and then this simplifies. You could divide them both by 3, so we have 2 times I plus 2 over 15. So this is like the ultimate simplified. On a test, I'd probably be happy there, but the goal is to get here. So there's your full lesson on complex numbers. Good luck.